Hi everybody, just wanted to make you a quick video of probably like one out of every section. First one says identify the domain and range of each. So remember, the parent function for a logarithm looks like that. The parent function goes through this x-intercept at 1, has an asymptote at x equals 0. Our domain is changed by where this asymptote is. The reason why our graph is only on the right side over here in quadrants 2 and 4 is because you cannot take the logarithm of a negative number or of 0. The answer to a log is the exponent, and there is no exponent that has an output of a negative number or 0. Positive exponents, like 3 squared gives us 9. 3 to the 0 gives us 1. 3 to the negative 1 gives us a third. See, none of these outputs are 0 and none of these outputs are negative. So how we find the domain and range, well, range is easy. The range is always all real numbers for all logarithms. But the way that we find our domain is by setting this argument, setting the inside of the parentheses equal to 0. So 4x minus 1 equals 0, x is a fourth. So that means that my asymptote is over here at a fourth, so my graph will have a domain of 0 or 1/4 to infinity. So my domain is 1/4 to infinity. All right, let's go down here and sketch. So for a logarithm, remember, we do our parent function first. Oh, these are all 10s. That kind of sucks. We do our parent function first. So we're doing y equals log of x. And since there's no base here, we're assuming it's a 10. We pick our values for y because it's a logarithm. So 10 to the y equals x. 10, the answer to a log is the exponent. To the y equals x. So 10 to the negative 2 is going to give me 1 over 100. 10 to the negative 1 is going to give me 1/10. 10 to the 0 is giving me 1, and then 10, and then 100. Now this graph is transformed right 2 down 3. So I'm going to take all my x's and move them to the right 2, so adding 2 to them. 2 and 1 100th, 2 and 1/10th, 3, 13 and 103. For my y's, I'm moving them down 3, I'm subtracting 3. So negative 5, negative 4, negative 3, negative 2, negative 1. So at 2 and 1 100th, I'm at negative 5. 2 and 1/10th, I'm at negative 4. 3, I'm at negative 3, and then 13 is at negative 2, so that's all the way over here. Just to practice domain and range here, my domain is 2 to infinity because of this asymptote right here at x equals 2. And then my range, of course, is all real numbers because it's a logarithm. Condense. When you're condensing, all coefficients become exponents. All subtraction becomes division. All addition becomes multiplication. So I'm going to condense this subtraction to one logarithm, a divided by b. Since a has a coefficient of 10, we have a power of 10. Since b has a coefficient of 5, we have a power of 5. Remember this 1/2. This is really log base 2 of x, 1/2. And remember, our 1/2 power is a square root. Okay, solving. I don't think I need to go over 11, 12, because those are just setting your insides equal to each other, just setting your arguments equal. But 13 you have to condense first, so let's do 13. So it is log base 7 of x minus 3 minus log base 7 of x equals 3. So we condense that to log base 7 of x minus 3 over x equals 3. So subtraction condenses to division, and now we're going to get rid of this log base 7 with an exponential base 7. So 7 log 7 is going to cancel, and then we have x minus 3 over x is whatever 7 cubed is. I think it's 243. $343. Good thing I checked. Cross multiply. So put the 343 over 1, and that's going to give me 343x equals x minus 3. Subtract x from both sides. 342x equals negative 3. So x is negative 3 over 342. Then that's going to be a no solution. Because if you take this negative and plug it back in right here, you cannot log base 7 a negative number. So this one is going to be our no solution. Let's look at 15. So this is an addition. So we're going to condense that using multiplication. So log base 5 of 4x squared minus 20 equals 1. So I'm distributing that 4. Again, to get rid of a log with a base of 5, we exponentiate on a base of 5. So 4x squared minus 20 equals 5. Add 20 to both sides. 4x squared equals 25. Divide by 4. So x is the square root of 25 over 4. Plus and minus. We have negative answer and a positive answer. And this one, oh, that's 5 over 2. Actually, both of these answers are going to work, because if we think about plugging this back in, and you can definitely graph it and look, but if you think about plugging in a negative, you're not plugging it in here at the 4. You're just plugging it in there, and we're squaring it. So if it was negative, it's going to become positive because we're squaring it. So both answers should work in this case. Evaluate, I'm just asking you for the exponent. 6 to what power is 36? 5 to what power is 1? That's all I'm asking you there. Okay, expand, we're going backwards from condensing. So all exponents become coefficients. All multiplication turns into addition. All division turns into subtraction. So I'm going to split up this division. So log base 6 of u to the 4th minus log base 6 of v to the 20th. Multiplying those together. And now my coefficients get to come out front. Pretty easy on those ones. Okay, let's see, exponentials. So I'm going to graph the parent function, and then I'm going to transform it. So my parent function is y equals 4 to the x. I'm going to pick my numbers. 4 to the negative 2 is a 16th. 4 to the negative 1 is a 4th. 4 to the 0 is 1, 4, and 16. Next, what I'm going to do is move it. So this plus 1 means I'm going to go left 1, and this minus 1 means I'm going to go down 1. So I'm actually going to be subtracting from both here. So left 1, negative 3, negative 2, negative 1, 0, 1. Down 1, so that is negative 15/16, negative 3/4, 0, 3, and 15. So negative 3, negative 15 sixteenths. Negative 2, negative 3/4. Negative 1, 0. 0, 3. 1, 15. This is scaled nice for us. Just to practice domain and range, domain is all real numbers, always on an exponential, and range depends on that asymptote. So since my asymptote is at negative 1 here, my range is going to be negative 1 to infinity. My asymptote is at the line y equals negative 1, coming from down 1. Let's see. Let's do an equating the base. So let's do this first one. 64 can also be written as a power of 2. So 2 to the 6th, yeah, 2 to the 6th is 64. So 2 to the negative 6th is 1 over 64. Now since my bases are the same, I'm going to set my exponents equal to each other, and x is 3. Let's see, let's do 36. So step 1 for solving is isolating the exponential. The exponential is the base and the power. The exponential has two parts, a base and a power. So I need to get rid of this multiply by negative 6 by dividing by negative 6. So 68 divided by 6 reduces to 34/3 positive. Then I want to get rid of my base of 4. So I'm going to log base 4 both sides. Log 4 is going to cancel, and I'm left with x plus 9 equals whatever the log base 4 of 34/3 is. Obviously 1.75125. Just kidding, not obvious. Getting x by itself by subtraction, I get negative 7.24875. You can always check your answer, graph it, see where these two things cross. That negative 68 is going to be super, super low on the graph. Because this is a negative 6, my exponential would face down like that. So we'd be, oh, and it's moving to the left 9. So it's probably something like that. And then negative 68 would be down there. There's your intersection. All right, let's see if I can get an inverse done in 2 minutes. I only got 2 minutes left in my video. So in an inverse, you need to switch x and y and solve for y. So I'll do this one with the e since y'all are afraid of Euler's number for some reason. Okay, switch x and y. Solve for y. So I'm going to add 6 to both sides. Now to get rid of a log with a, to get rid of an exponential with a base of e, we have to natural log both sides. Look how I'm doing the parentheses. Natural log and e cancel out. So my inverse is the natural log of x plus 6. Whew, still got a minute. Okay, I'll do another one. So notice how minus 6 is not on the inside, but now plus 6 is. That's important. That's inverse. So again, switch x and y. Solve for y. I have to cancel out this base of 4 first, and I do that with an exponential. So 4 to the, whoopsies, that doesn't cancel out. 4 to the x equals 4 to the log 4. So I have 4 to the x equals y plus 8. So my inverse is 4 to the x minus 8. Notice how the 8 is in the inside, and now the negative 8 is on the outside. That's important for an inverse.